Hey guys, up to this point we've had a lot of conversation about our successors, our feasible successors, our feasible distance, the advertised distance, and this concept of the feasibility condition. And what we've done is we have a topology where our infrastructure is not able to do load sharing because we have the best metric being installed in our routing table. However, in this particular configuration, we have a feasible successor, and that feasible successor is going to allow us to be able to do load sharing if we do the proper configuration to support it. And that's what I want to highlight right now. First of all, let's just illustrate the point one more time. I'm going to go ahead and erase some of this output or this console stuff. And what we're going to do is let's take a look at what's going on R22. I'll repeat this trace route. What we see is we're going through 3. We're not load sharing through R2. And if I look at my topology table, show IP EIGRP topology table, and I scroll down until I get to my 11, 11, 11, what we see here is I only have one successor. I have a feasible distance, which is going to be the metric of that prefix, which is 537.888, which is this link right here through serial 2/1. The link through serial 20 is still in the routing table. I mean, still in the topology table, but it's not being installed in the routing table. And it's not being installed in the routing table because this metric is higher than this metric, but it's being placed in the topology table because the administrative distance is less than the feasible distance of the best route. So I know that this route right here is loop free. Now what I want to do is I want to change this behavior. I actually want to do load balancing across all of these links. And the only way that I can do that in this paradigm, because this value and this value are different, is to do something called unequal cost load balancing. Now, how can I do this? Well, there's a command, variance. Now, variance allows me to define a coefficient, a value, a numeric sequence. And what it's going to do is it's going to say, well, how many times worse can a prefix be, or can a metric be, before I use it for load sharing? So what I say is if I say 2, that means this value right here could be twice as bad as this one, and we would still implement it. So if I want to do load sharing, let me go ahead and do some erasing here. If I want to do load sharing in an unequal cost fashion, let's take a look at the prefix. So show IP route 11.11.00/24, and notice I have only the one prefix. And notice my share count here is 1. Now, what I could do is I could config T router EIGRP 10, and I can employ the variance command. And it gives me the capability of entering a numeric sequence between 1 and 128. Now, if I don't enter a value, if I just come up here and hit variance, I have to enter a value, but if I hit, let's say 2, that means that a prefix listed in the topology table with a metric that is going to be 2 times worse than my prefix that has been fixed as my successor can be used for the purposes of load sharing. Now we know mathematically what we just did is going to allow us to be able to do load sharing because we were only something like 10 or 20,000 off. Let's take a look and see what's going on here. So I'm going to say end, and I'm going to say show IP topology table, IP EIGRP topology table for 11.11.00/24. And I see the 2 entries. So mathematically, if I take a look at these 2 values, so if I take 537.888 and I take actually let me redo this. If I take 563.488, I mean, just looking at this, we can tell that we're a good 20 to 30,000 off with regard to that value. This one being the lowest, so that's going to be the successor. This one, whereby the advertised distance of this one right here, which is the 51488, is less than this value, so this is going to be a feasible successor. Now what we did is we used the variance command. We used the variance number of 2, a coefficient. So that means that this prefix right here, or this metric, could be up to 2 times worse than this one, and we would still do load sharing. So let's take a look at what the outcome is. So on this device, show IP route, and let's scroll down till we get to 11.11.0, and notice now we're load sharing. We're load sharing, but our metrics are off. They're different. And that is again because of this idea of the variance command. Now notice the variance command affected every prefix being learned on our device. There is no way to be able to single out particular prefixes and affect them using variance. It's an all or nothing ordeal. And the main goal here is we need to understand now exactly how the system is going to be managing this idea of load sharing. Since it's going to be sending information across these links in an unequal cost fashion, let's look and see how the system is going to actually accomplish that. So what we'll do is I'm going to type show IP route, and I want to look at 11.00.255.255.255.0, and what we're going to see here is I want to look at my share count. Notice it's going to send 240 packets versus 229 packets. So the one that is going to be the faster is going to be, or the one that's going to be the best, is going to actually carry more traffic per second than the one that is less. I'm sorry, the one that is less attractive, so the one that is actually has a higher metric. So this tells me that my share count is going to be slightly off, because remember, we're only just a little bit out. But what ends up happening if I go in here and I do something absolutely insane? Let's see if we can't place the highest possible delay on E03 coming down from R2 going to Cat1 and see what the outcome is with the variance command. So what I'm going to do is I'm going to go over to R2, and on R2 I'm going to say delay, and I want to use the biggest value possible and hit enter. And remember, that's in tens of microseconds, so we'd have to add another 0 off to the end of this. Now let's go back over to R22 and see about our load sharing. Notice it's not in the load sharing anymore. Well, okay, can I do trace route just to see? Trace route to 11.11.0.11. I'm only going through R3. Well, let's take a look at that topology table entry. Notice I only have one entry. I have one successor, and I now have no feasible successors in the routing table. Let me scroll up just to illustrate that point. There's nothing else in here. I only have the prefix from R3 that I'm using. And the reason being is the advertised distance of the prefix that I'm learning from R2 is inordinately high, and its administrative distance is actually greater than my feasible distance, which means mathematically R22 cannot determine whether or not traffic from R2 has been passed through itself. So in other words, we're going to turn this off as a loop prevention mechanism, and we're going to prevent this entry from being placed in our routing table. Now, since it's not in the topology table, it can't be placed in the routing table, and since it's not in the topology table, the variance command has no effect. Watch this. I'll come up here and go config t router EIGRP 10, and I'll say variance, and let's give it 128, the highest value possible that we can enter. And let's look and see what's going on. Show, actually I'll just up arrow and look at my topology config. Notice we still only have the one entry in the topology table. The reason being is this variance only allows me to do unequal cost load sharing across prefixes that have been planted inside of the topology table. And the reason that I talk so extensively about the feasible condition is that I need you to understand why information is placed in the routing table. The administrative distance of the prefix for 11.11.0.0/24 that I'm learning from R2 is going to not be used because the AD that's being communicated to R22 is not going to match the feasibility condition. In other words, the AD is going to be higher than my own feasible distance, which means I cannot determine whether or not the path has looped or not through me. Now, what I want to do is, regardless of how high I go on my variance, I can't change this behavior. So let's take a look and see exactly what's happening, because there's another command that I want to look at here. I'm going to show IP EIGRP topology, and let's see if I can use an all links. So all dash links. And let's scroll down until we get to 11. Notice 1100 still only has one entry. In fact, everything that we're learning from R2 is not going to have an entry in the topology table. It's being ignored. It's being ignored because it failed the feasibility condition. So we saw what happens when we change the feasible distance, or we manipulate the feasible distance on a local device that's going to be reported to an upstream device as its administered or its advertised distance. And we did that through the manipulation of our delay. I showed you how we could turn off bandwidth for the purposes of our computations, and we just simply did the manipulation through the concept of delay. So keep in mind, we cannot place a prefix that's not in the topology table inside the routing table. We cannot do load sharing across links that do not at the very minimum match the feasibility condition. If we have links that match the feasibility condition, all we have to do is use the variance command, because both of those prefixes are going to be installed in the topology table, and they can be candidates for being installed in the routing table based on what we implement for the variance configuration. So it could be X number of times worse than the actual feasible distance. However, if a route never qualifies to be placed in the routing table, irregardless of how high we set the variance, it will not be considered to be placed in the routing table or used for unequal cost load sharing. With that wrapped up, I'll see you guys in the next video. I hope this helped you out. See you there. Bye-bye.